Hey gang, my name is Johnny Pujol. I'm a water quality engineer with TapScore, and today I'm going to walk you through a laboratory water test for a well water sample. I'm going to show you how to read the laboratory report, show you some of the cool features of a TapScore laboratory report, and hopefully answer some of your questions about understanding laboratory water testing and drinking water quality in general. So let's get right into it. All right, every laboratory report, also called a certificate of analysis or COA, these are kind of interchangeable terms, is going to have some kind of identifier. In this case, it's a 6-digit alphanumeric XGGEK4. This is just a way of keeping track of all the different samples that come to the laboratory for testing. And if you have many samples that you're testing, either because you have many wells or you test once every couple of years, you will appreciate having them each named something slightly different. Every sample also has a chain of custody or sample information associated with it. So you're going to see the time and the date the sample was collected, where it was collected, maybe a photograph, how the sample was collected. These things matter a great deal, especially if later you're going to buy some filtration or treatment technology and you're going to give this report to a company for them to install some filtration or treatment technology. They're going to want to know, who collected the sample, when did they collect the sample, was it a fully flushed sample or a first draw sample? These are all kind of important details that you get when you're collecting your sample and sending it into the laboratory, and they're kept close to the results because you really can't make sense of the results if you don't have the sample information handy. So TapScore has all of that nice and neatly organized on the top of every report for you. Now, TapScore does evaluate your water on a scale of 1 to 99. This isn't a perfect system, but it's a very helpful system, certainly an intuitive system for getting a sense of where you are. So this is not a good sample. We're scoring a 34 out of 99. If you've got 99 drinking water on the TapScore evaluation algorithm, it's outstanding. 34, not good. It's kind of like school grades. So if you're below a 70, there's something you got to work on. Some general high-level pictures here of the water quality for this sample. It's got 7 health concerns, 4 concerns related to aesthetics, so tastes and smells and colors. We'll identify those in a moment. And then 1 concern related to plumbing. So very high-level analysis of your TapScore report is up there on the top. Scrolling down here, see some of the key details from that chain of custody. Again, the date and the time, the location, whether the sample was filtered or treated or not. And then sooner or later, you get down here to what I would consider like the main navigation for your report. And you're going to see an all results section, a properties, health, aesthetics, plumbing, treatment, and comparisons section. And I'll go through each of these one by one. Perhaps the most important one, though, is this first one, all results, where you can search by contaminant, let's say lead, and look at just the lead result, or you can look at all your results. You can also change the way you view all your results up here by clicking Change Evaluation. There are different organizations out there, state organizations, federal organizations, academic institutions that tell you, hey, what is the safe level of a particular contaminant? And those are not always the same number. So the maximum contaminant level set by the EPA is one set of standards, the set of standards that utilities need to abide. But you also have a much more rigorous or aggressive, conservative set of health guidelines called the HGL, which is essentially the combination of all the state and federal MCLGs, the kind of goals for ideal drinking water quality. So you can choose which of these standards do you want to compare your drinking water to, and you can switch between them. I'll switch it over to HGL for the moment, just to show you that it changes. I'll come back to EPA MCL. And what you see when you do that is that your results are compared against those standards and evaluated according to those standards. So evaluation is MCL here, EPA MCL. So yellow bar means what you think it means. It means that the result was a bad result. So in this case, total coliform being detected is a problem, and that is shown by this yellow bar. Now, there are quantified contaminants as well, of course, like arsenic, detected at 7 parts per billion here. I'm hovering my mouse over so you can see the unit conversion. I'm also seeing here that 7 parts per billion ain't terrible, right? A little bit of blue there. But just to give you a taste of how this evaluation thing work, I'm going to switch over to HCl. You'll see now that arsenic level is yellow. The reason for that is the HCl is more conservative than the MCl in recommending the safe level of arsenic. So you can do this for all the contaminants in the laboratory sample. You can see what was detected. You can click on them, learn more about the contaminant, where it comes from, its common sources, the health effects of that contaminant, and ultimately treatment and filtration recommendations, different types of technologies that are going to work to reduce that contaminant in your drinking water. Every lab report needs to have details on the instrumentation and methodology used for analysis. So we've got that here in this, double-clicked it by accident, this section called Method, MDL, and RL. The method is going to tell you what laboratory instrumentation and process was used for analysis. Some of the most common ones in metals testing, for example, are EPA 200.8 and EPA 200.7, so you'll see those often. Another very common method is the analysis for VOCs, EPA, where we have it. Let me scroll down here, 524.2, 524.2, 524.2, these are all VOCs. Anions by EPA 300. Each of these methods is an established and kind of a rigorous protocol followed in the laboratory for running your sample according to a kind of an established process. And every drinking water laboratory has to choose these different processes that they're going to use to analyze your sample. And if you wanted to read more about those instruments, those methods, you could do so by researching them online. They're very standardized. Every instrument, every method in a laboratory has a detection limit. So you can see only as low as a certain concentration for every contaminant. In this case, arsenic's detection limit, it's kind of small, I'm squinting here, is 0.00005 ppm. So that's about 0.5 ppb, or 0.5 micrograms per liter. You don't really need to see lower than that. Any lower than that is all just very, very, very tiny. So every method, every analyte has a detection level and a concentration below which you can't see. And you kind of say, oh, it's zero. It's not technically zero. It's actually called non-detect. So if we were to scroll down here, I think you'd see some non-detects. Like down here, copper was not detected. Cobalt was not detected. E. coli was not detected. That means at the detection level of that instrument and that method, nothing was found in the sample. You see the date. This was a while back. This is 2019. For reference, it's now October 2024, so this is an old report. Okay, so you can look at this in a couple different ways. There's a grid view, this row view, which I tend to prefer. You can view all the analysis details of each of these contaminants by clicking on it, getting some comfort with the information there. You can click over here to the properties section and read about the properties of your drinking water. These are not necessarily contaminants, but like general properties of water quality, things like pH and the LSI or the hardness, the TDS, and generic properties of the water itself. Read about them, whether your values are high or low relative to the norms. You can see the health-based recommendations in your drinking water. So various contaminants that have, in this case, developmental risks, potential or known carcinogenicity, so whether they cause cancer or not, effects on immune system, kidney health, liver health. I mean, we go into all the detail for every contaminant and how it might affect someone's health, and you can kind of click to learn more about those health effects. Under aesthetics here, you can see the colors, tastes, and smells broken out by contaminant. So what are the effects of iron or xylene or total coliform on the tastes, smells, and colors in your drinking water? And then you can see the plumbing section, which contaminants are ultimately responsible for maybe hurting the plumbing or the appliances in the home, washing machine, dishwasher, shower heads. See which contaminants in the report are affecting those appliances at the house. Then you have this treatment section, which is going to help you get smart on taking the results from this all results section and the insights from these various sections we just ran through. And the treatment section is going to give you kind of personalized recommendations on the right water filtration and treatment technologies. There's 20 plus filtration technologies out there, and they all do different things, and they all work better in some situations with certain contaminants than others. For example, coliform bacteria, you're going to need something like chlorine or UV light. So you can read about all these different contaminant reduction technologies, these filtration technologies, and for each of them, you can scroll down and you can see, I'm going to granular activated carbon. You can see which contaminants in your water will that technology be best for, and what will it not be best for. And since there's a lot of different contaminants in your report and a lot of different technologies, I find this treatment table view really nice because you can see all the contaminants and all the technologies in one spot. And those blue squares show you which technologies, like reverse osmosis, are going to reduce which issues in your water. Finally, you can share your report with nearby WQA accredited filtration providers and get their quotes on different systems. Again, TAPSCORE itself is 100% unbiased. We do not sell filtration or treatment technology or affiliate links of any kind, but we do make it easy for you to share your report with others so you can get quotes from filtration experts. You can also share your report with family and friends, of course. The last tab here I promised we would click on is this comparisons tab. This is a great place to go if you want to compare your sample to nearby results from groundwater, like private wells, surface water, the state as a whole, in this case, the California sample. So this is the average of California well water samples, the average of California utility water samples. You can look at national results, compare your results against national wells and national utility connections. And you can also compare it to bottled water. So obviously we all think about bottled water and wonder, is our tap water much better, much worse than bottled water? Well, here you can compare it directly. And if you have multiple lab reports, because you've done different tests with TAPSCORE, you can compare the results across different tests and see how your water quality is getting better or getting worse. So that's a wrap. There is more on the report, but I'll trust you to ask any questions you have based upon the video or based upon other questions and comments in the comments section below. We answer them as quickly as possible. More than happy to be your helping hand when it comes to understanding your drinking water quality. So if you have any questions about this report, about lab testing in general for drinking water, or about your tap water or filtration, do ask those questions in the comments below. We'll be more than happy to help. You can also go to mytapscore.com. We have an outstanding resource in our blog and in our professional live chat where you can talk with our team, and we can help you find the right water test, help you understand your lab report, and everything in between. Thanks so much for listening, and look forward to seeing you next time. Bye-bye.